Okay, so this is section 5.6. It's the remainder and the factor theorem. And go ahead and try number 9 based on what we did yesterday. You're going to divide that p of x polynomial by x minus 3 and use synthetic division. So go ahead and pause the video and give that a try. So if you need a little bit of a hint, remember that you have to put the polynomial in standard form, and we're going to use a 0 anytime a term is missing, and this polynomial doesn't have an x term, so we're going to put a 0 there. If you need to repause the video and try again, go ahead and do that. If not, hopefully you did your synthetic division and you got 2, 5, 15, and 70. And so this becomes 70 is the remainder. We now make a depressed polynomial using 2, 5, 15, and 70. And it starts 2x squared. And then we take our remainder and we put it over our divisor. Now, try letter B. What is the value of p of 3? So use the same polynomial from up here and find p of 3. Go ahead and pause the video and do that. Now I'm assuming that you took 3 and substituted it back into the p of x formula. And when you got that, you did p of 3 and you got 70. What you just did is called direct substitution, where you took the 3 and directly substituted it into the polynomial. If you notice, it's not a coincidence that p of 3 is 70, and when we divided and used a 3 for our synthetic division, the remainder was also 70. And so this is the remainder theorem, that if you take p of x, you divide it by x minus r, the remainder k, which in this case is 70, is equal to the value of the polynomial at r. Now remember, x minus 3 was our x minus r. Our r value was the 3. So over here it says p of r equals k. So when we did 3 for our synthetic division, the remainder 70 is our p of 3. That's called synthetic substitution. So instead of doing direct substitution, we could have done this synthetic substitution. Now you wouldn't write this quotient. If you were trying to find what p of 3 is, you would just do the synthetic substitution and say p of 3 is 70. You never use the depressed polynomial. So now try letter C, evaluate p of 5. So again, you're going to use 5 for your r value, do synthetic substitution, don't get a depressed polynomial. Go ahead and give it a shot. So this should have been your setup. And now again, we're not going to depress the polynomial at all. We're just going to say p of 5 is 250. That is synthetic substitution. If you ever wanted to check your answer, you could take 5 and substitute it into the original question doing direct substitution, and you would also get 250. Now, there is a use for this. We kind of overlap synthetic substitution and synthetic division for different reasons. So there is a use to it, and we'll get there. All right, so now go ahead and pause the video. See if you can do 10 and 11 on your own. So number 10, this is your setup. And then make sure we're writing our final answers properly. It's really important that we identify what it is, what the original question was asking, and making sure we answer that question appropriately. If you need to, pause and try number 11. All right, this time hopefully you remembered a 0. And again, h of 1 is equal to 6. So that's synthetic substitution. So now let's look at number 12. Number 12 says determine whether x minus 3 is a factor of, and then it gives you a cubic polynomial. Then find the remaining factors. So let's start with the first part, determine whether it's a factor. So this is from yesterday's lesson where you're going to do synthetic division with your R value. So your R value in this case would be 3. Put your numbers 1, 4, -15, and -18, and do synthetic division. And what we're looking for is a 0 remainder. So in this one, the remainder is 0. And so that answers the first question. Is it a factor? Yes, x minus 3 is a factor because we got a remainder of 0. So the next part of the question is saying, then find the remaining factors. So because it was a factor, we can now find the other factors of this polynomial. So in this case, we're going to depress our polynomial using 1, 7, and 6. And then what we can do is take this quotient and factor it to get the other factors. So factor this quadratic, however you normally factor quadratics. And those are your other two factors. So the other factors are x plus 6 and x plus 1. So x minus 3 was a factor in the beginning, and then x plus 6 and x plus 1 are the other factors. Pause the video, try 13. So here we have, yes, it is a factor because the remainder was 0. Depress your polynomial, which this is a little bit harder of a factoring question, but it is factorable. Pause the video if you need to and take some time to factor that. And so my other factors are 4x minus 1 and 3x minus 2. Okay, question 14. Very similar to numbers 12 and 13, but a little bit of a very subtle difference. First difference is that they are telling you one of the factors. So in both question 14 and 15, this underlined f of 2 equals 0 and this x plus 3 is a factor. Both of those things are telling you here is a factor, right? As opposed to in number 12 and 13, it was saying determine whether this is a factor. Like we weren't sure. In these two questions, we are sure. They are handing us one of the factors on a silver platter. The other difference between these two questions and the two above it was that our goal here is to factor. The ones above it, it was like find the other factors. So in this case, we're listing all the factors. So the fact that f of 2 equals 0, that tells us a couple different things. Right now, what's important is that x minus 2 is a factor. This 2 is the r value. So 0 is going to be the remainder. Oops. Okay. So remainder is 0. So that when I use 2 for my synthetic division, what's going to happen under here is that I better get a 0. If I don't get a 0 for a remainder, something is not right. Okay, and most likely you did some sort of miscalculation. So here's our synthetic division. We got a remainder of 0, which we knew was going to happen this time because they told us it is a factor. I'm going to depress my polynomial. I'm then going to factor this, difference of two squares. And notice how I'm going to write my answer differently compared to numbers 12 and 13. The goal of this was to factor. That's my final answer. To check my answer, which I probably wouldn't have time to on an assessment, but if I wanted to check my final answer, I could multiply all of this out, and what should happen is that I get the original f of x polynomial, the cubic. Most common mistake is that people will forget the x minus 2, which was this given up here, and they'll just say the answer is x plus 3, x minus 3. But hopefully you say to yourself, wait, something's not right because I know this final answer. If I multiply it out, it should get me the original question. And x plus 3, x minus 3 definitely doesn't get me this cubic. So what did I do wrong? And then you say, oh yeah, I forgot to bring down the given factor in the original problem. So Go ahead, pause the video, see if you can do number 15 on your own. So they told me x plus 3 was a factor, so I'm using -3, my r value, for my synthetic. We knew that there was going to be a remainder, so that's not a surprise. I would be surprised if it didn't happen. Depress your polynomial. Factor it. Now, what happens if this is not factorable? If this is not factorable, then your final answer would be x plus 3 times this quadratic. And then that would be your answer. But this can keep going. And so put all the factors together, the given one in the beginning and the ones that you just found. So again, notice the difference between the questioning for this whole lesson. We are using the same skill of synthetic either division or synthetic substitution. But again, notice the difference in how we write our final answers. Lots of different things. So pay attention to the wording of questions as you go along in practice. And I hope you guys found this helpful.